Assalamualaikum. So today I'm going to do question 3C from the past year question CPP 2017. So let's look at the question. A gas stream contains 18.0 more percent hexane and the rest nitrogen. The stream flows to a condenser where its temperature is reduced and some of the hexane is liquefied as shown in figure 1. The mole fraction of hexane in the gas stream leaving the condenser is 0.05. Liquid hexane condensate is recovered at a rate of 1.5 liter per minute with a density of 0.659 kg per liter. So here is already given the diagram for the process. So let's just redraw another diagram for better understanding. So here is the diagram. So let's just name this as N1, N2, and N3. So at the liquid condensate, almost 100% of hexane is condensed from the condenser. Means here is pure hexane being condensed. And we also had the information of volumetric flow rate and the density of the liquid condensate. So first of all, we must convert this into mass flow rate. So mass flow rate is equal to volumetric flow rate times with the density, which is 1.5 times 0.659, and that gives us 0.9885 kg per minute. So note that in our system, it is given the composition in terms of mole percent, which is mole per mole, but in here we have the mass flow rate. So for a better calculation, we must convert this into molar flow rate. So as we already know, the molecular weight of hexane is 86 kg per k mole. So based on the formula, molar flow rate is equal to mass divided by molecular weight. So the mass here is 0.9885 kg per minute divided by the molecular weight is 86 kg per k mole, and the final answer is 0.01149 k mole per minute. So let's just convert this into mole per minute. So 1 kmol is equal to 1000 mole, and the final answer here is 11.49 mole per minute. Means that the molar flow rate of the liquid condensate is 11.49 mole per minute. So let's look at the first question. What is the flow rate of the gas stream leaving the condenser in mole per minute? So in this question, it asks us to find the value of N2. In order to find N2, we must do the mass balance. So since it is non-reactive, so mass in is equal to mass out. So for the overall mass balance is equal to N1 is equal to N2 plus N3. So here we already have the value of N3, which is 11.49. Then we perform the species balance for hexane. So given the composition of hexane in the inlet condenser is 0.18 times N1 plus, is equal to 0.05 N2 plus 11.49. So this is equation number 2. So at the end of the simultaneous equation, we get the value of N1 is equal to 83.97 mole per minute, and N2 is equal to 72.48 mole per minute. So here is the answer. So let's look at the second question. What percentage of the hexane entering the condenser is recovered as a liquid? So in this question, it requires us to find the percent recovery. So percent recovery can be defined as the hexane in liquid condensate divided by hexane in fresh feed. Okay, so we already have the value of hexane in the liquid condensate, which is 11.49 divided by the composition of hexane in the inlet condenser is 0.18 times with N1, which is 83.97 times with 100%. So the percent recovery of hexane is 76.02%. So here's the answer. Hello, welcome back. So here is another question of reactive system from 2018 CPP, question number 3. Given the two reactions of interest below, so we basically have two reactions involved, named reaction A and reaction B. So the species distribution in the inlet and outlet stream is shown in table 2 below. So this is basically the table that explains the inlet and outlet of the reactor. So let's just draw a diagram that illustrates this table. So this is basically the chemical species of inlet and outlet of the reactor, and we have two reactions here, reaction A and reaction B. So let's just name this C1, this as a C2. So now look at the first question. Determine N1 and N2. So here we must find the N1 and N2 in terms of mole per hour. So in this case of study, we must find the extent of reaction first. So extent of reaction. So we start with Cl2 first. It's equal to 170 minus C1 minus C2 is equal to N1. C3H6 680 minus C1 minus C2 is equal to N2. So next is C3H5Cl. So note that the inlet of C3H5Cl is 0, so we can simply put the value of 0 here. So plus C1 is equal to 4.6 Next is C3H6Cl2, 0 as well, plus C2, 24.5, and the last one is HCl, 0 plus C1 is equal to 4.6. So in this case, we already have the value of C1 and C2, which is C1 is equal to 4.6 and C2 is equal to 24.5. And this unit of C is in mole per hour. So we substitute the value of C1 and C2 into Cl2 and C3H6. Then for Cl2, the value of N1 is equal to 140.9 mole per hour, and for C3H6, the value of N2 is equal to 650.9 mole per hour. So this is our answer. Next, move to the second question. Cl2 is the limiting reactant, whereas C3H6 is the excess reactant. Calculate the percentage by which C3H6 is in excess. In this case, we must find the percentage excess of C3H6. Okay. To find this value, we must find the NS, which is we must find the N, which is the actual mole, and the NS, which is the theoretical mole. So first we find the theoretical mole first. So based on the chemical reaction, which is Cl2 plus C3H6, will give us C3H5Cl plus HCl. So it means that 1 mole of Cl2 will react with 1 mole of C3H6. So in this question, it is given that Cl2 is the limiting reactant. So we can calculate the mole of other reactants. So in this case, 170 mole per hour of Cl2 will react with 170 mole of C3H6. So that is our NS, 170. Meanwhile, for the actual mole is 670 mole per hour. So based on the formula, N minus NS over NS times with 100. So 680 minus 170 divided by 170 times 100. So we have the value of 300%. So this is our answer. So next question is, what is the extent of reaction C for reaction A and B? So in this case, we already wrote the extent of reaction during to find N1 and N2. So next question. What is the fractional conversion X of C3H6 to C3H5Cl? So in this formula, in this question, we must we must use this formula. So NS is equal to NS naught minus NA naught. So XA. So VS over VA. So the NS here is referred to molar flow rate of molar flow rate of C3H5Cl, which is 4.6, is equal to NSO is equal to 0 minus 680, so XA. So the number of mole of C3H5Cl is -1 over +1. So XA is equal to 6.76 times 10 to the power of -3. So next question. What is the fraction of C3H6 converted to C3H5Cl2? So mole of C3H5Cl2 is equal to 22.5 mole per hour, and mole of C3H6 is equal to 680. So we just find the fraction by dividing C3H5Cl2 divided by C3H6. So 24.5 divided by 680, and that's equivalent to 0.036. So next question. Find the selectivity of C3H5Cl relative to C3H6Cl2. So this question is actually similar to the previous question, which is E. So in selectivity as well, we must find the mole flow rate of C3H5Cl, which is equal to 4.6, and number of mole of mass flow rate of C3H6Cl2, which is 24.5. So we divided these two value. So 4.6 divided by 24.5, and that is equal to 0.1878. Now we come to the last question. Determine the yield of C2H5Cl per mass of C3H6 fed to the reactor. So write your answer in gram of C2H5Cl produced, gram of C3H6 fed to the reactor. So in this case, it is given the reactor outlet in terms of mole per hour. Then we must convert this into gram per hour. So in order to do this, the mole per hour times with our molecular weight. So using this formula, we can obtain the value of mass flow rate. So for the first chemical species is C3H5Cl. So the mole flow rate is 4.6 mole per hour times with 76 gram per mole. That is equal to 349.6 gram per hour. And next is C3H6. Okay, so the mole flow rate is 650.9 mole per hour times with 42 gram per mole, and that is equal to 27337.8 gram per hour. So look at the question. So it asks us the yield of C2H5Cl per mass of C3H6. So means that yield is equal to mass of C3H5Cl divided by mass of C3H6. So 349.6 gram per hour divided by 27337.8 gram per hour. So our final answer is 0.013. That's all. Thank you.